You are on top of a cliff that is 600 meters tall. You decide to pick up a rock and throw it parallel to the ground at 27 meters per second. What is the total hang time? How far does the rock land from initial position in the x direction? And what is the rock's velocity right before it hits the ground? Let's start off by breaking this problem down into x and y components. On the x side, we have a velocity of 27 meters per second. And on the y side, we have gravity multiplied by time in seconds to get a velocity in the y direction. The way the gravitational acceleration works is every second that passes after the rock leaves your hand, the rock's velocity will increase by 9.81 meters per second towards the ground. The equation we can use to find velocity at a given time is 9.81 meters per second times time. If we integrate this formula, we get the position formula of 1/2 gravity times time to the second power equals position. To find the hang time, we need to find how long it will take the rock to cover the distance of 600 meters in the y direction. We can use the position formula of 1/2 gravity times time to the second power equals position. We can plug our gravity of 9.81 meters per second and our height of 600 meters into the formula. After doing some rearranging of formulas using algebra, we get that the rock will be in the air for 11.06 seconds. The hang time is 11.06 seconds. To find how far the rock lands from initial position in the x direction, we can plug 11.06 seconds hang time into the y position formula of 27 meters per second multiplied times time. After plugging in our numbers, we get that the rock will land 298.62 meters from initial position in the x direction. Finally, to find the velocity right before the rock hits the ground, we first need to find the velocity in the y direction. In order to do so, we can plug the hang time into the equation for velocity in the y direction of 9.81 meters per second times hang time. We get 108.5 meters per second in the y direction. It is a common mistake to use this value alone as a velocity before hitting the ground. In order to get the correct answer, we must use the Pythagorean theorem with our velocity in the x and y direction on each leg of the triangle. And we can solve for the hypotenuse, which will be the velocity right before the rock hits the ground. Once we plug in our numbers, we get 111.8 meters per second as the velocity right before the rock hits the ground. And that concludes this video. Hopefully I've earned a like, share, or subscription. Thank you for watching.